I just started. I think we can get started whenever you're ready.
Okay,
Yeah.
great. Hi guys. So I'm Ashley Reddy, and I'm CEO of a company called Rational Robotics. And I was fortunate enough to come to San Diego to participate in something called the Qualcomm Robotics Accelerator, which happened just up the street here on Lusk at the Qualcomm Research Facility. And that's how I met Hansel, and he invited me to this event. So thank you very much, and for giving me this opportunity to kind of do a brain dump, run my mouth, or whatever on kind of the general topic of robotics and various other things related to that. Since this is a very kind of small and intimate group, I thought we would just keep it very kind of informal, and I'll start talking about different subjects, and you guys could kind of tell me, you want more technical or less technical, or more of, I guess, whatever you guys want. So just a quick little intro to my company. I'll start by telling a story about how it all kind of happened for us. So many years ago, back in high school, I went into engineering, and my childhood friend went into the trades. He went into basically automotive refinishing and repairing, collision repair, all that other stuff. And then I went to visit him at work and saw what he did for a living. He was in a paint booth, like he was painting a car. And he's got like this suit on and stuff, a respirator, and he's painting a car. And I'm like, okay, cool, let's go, out and grab a beer or something. And I'm like talking to him, thinking, you know what? In 20 years, your job has to be automated. I don't know if you have, a life in this industry. And then he goes, well, there's so many problems with it, right? I mean, think about it this way, robots they do it in the factory, sure, but those robots are dumb, and they make it work because they spend, millions of dollars at it, and then they program it to paint something or do something, but they make their money back, of course, because they do 1,000 of the same thing, right? So basically it works at scale, and robots are expensive. So surely this is going to be automated. So winding the clock forward 20 years, I go visit him at work, and he's doing the exact same thing, exact same process. They're refinishing car parts, basically. And I thought, okay, hold on a minute. This much time has passed. Surely somebody's thought about automating this, or somebody's done something about it. But it turns out nobody's really brought robotics or automation into that field at all, right? And then I looked at the economics of it, and it turns out, just in the US alone, collision repair is a $40 billion a year industry. And the reason you don't hear about it, you don't see it, is because of the opacity of the insurance companies. When you get into an accident, all that financial transaction that happens, basically you're not shelling out the money to the guy who repaired. Your insurance company is, right? So you're not seeing the thousands of dollars changing hands. So I thought, okay, so there's definitely a market there. The technology, I've had 20 years of experience to then build from what I knew back then to what I knew now, and with all the cool innovations that have happened, I thought, okay, well, is this really possible? So we looked into it, and it turns out, yeah, it is. So basically, getting to the point of what my company does for a living, we automate the task of painting. So basically, we've disrupted painting for parts, with robotics. Our long game is, of course, to do it for the collision industry, to kind of attack this very large market and to kind of make money on all these small transactions that are happening throughout the country. But it turns out that industry needs our robots as well. So I looked into industrial robots and kind of their kind of level of sophistication and how smart they are right now. And it turns out that the robots that you've seen like in the 1950s and 60s, like picking up parts and kind of moving it here into a machine. The machine presses the part, and it takes it and moves it somewhere else. We've all seen that video. Yeah. Turns out they really have not gotten a lot more sophisticated than that. So basically, they're not able to react to different types of parts using the same kind of line. They're not able to to make the economics work at kind of smaller volumes. So that's what our company does, is basically we use computer vision to solve that problem, to automatically program the robots to do the various tasks. So I will show you a little video here about our I guess our latest project that we're working on. So, okay, I'm no Martin Scorsese, so my video, shooting ability is really bad. But hopefully you can see right here. Let's give you some context here. So this is a professional car painting robot at a facility in Germany, and what it's going to do is to it's going to paint this part here. And the neat thing about it, it's actually using our system to program the toolpath. So, kind of hard to see here, but
When you say the toolpath, is that a one-time deal that it has to take this
Yeah.
one time?
Could you point out what we're looking at here?
Sure.
Which part?
Here's the robot,
Oh, okay.
and here's the door, basically.
Is it
Yeah.
in the door?
Yeah, it's painting a car door. This is actually, it's doing it for Volkswagen. So basically, this is through a company called BASF that sells Volkswagen to paint the part. And this is basically the robot now going and painting that part. Now, normally this process takes them 4 hours to do any one part. So in other words, when they have a new part they have to kind of paint for a new Volkswagen car or something, basically it takes them 4 hours to figure out how to paint that part. We've reduced this down to under a minute. And the way we've done that is basically our system consists of 3D cameras that basically do a real-time 3D capture of the part. Then the software does toolpath planning. And then basically it has an internal simulation engine to make sure that it gets optimal coverage. And then once that toolpath is generated, we send it to the robot to paint the part. So we can interface to not only our own robots, but also to kind of off-the-shelf robots like this that are made by companies like ABB, KUKA, and so on.
So the existing system, if I
Yes.
understand this right, it will paint like 1,000 cars
Yes.
relatively fast once it's set up.
Yep.
And your process will be the same thing.
Yep.
Except it's just faster to set up. That's all.
It's faster to set up, and it could paint 1,000 cars, as you said. But what it could also do is it could paint a door from this car, and then a minute later it could paint a bumper from a different car. It could paint a hood from a third car. It doesn't matter because it's able to do those tool paths pretty much in a minute or two.
Is there actually an assembly line that has those different parts coming through?
So that's my point entirely, is that not only does it solve this problem for the one-time setup of assembly lines, but with the collision industry, for example, when they have people painting parts individually, they're doing a fender 1 hour, they're doing a door the next hour, kind of thing. And that's the person that we're trying to replace there, is the person who does like the one-ofs. And that is a very huge industry.
Have you looked at Amazon's task of packaging various things?
Yeah, like the packaging challenge that they've had, and yeah, we're familiar with that particular problem case as well. Yeah.
Can you solve that problem?
We want to compete in it, but I'll tell you the problem with Amazon is they're cheapskates. So their prize, we're pretty sure we could win it, but their prize for it was something like $25,000 or something just ridiculously small.
25,000 to replace one person doing this.
No, just basically you give your IP to them once you win, and they give you $25,000.
It's
So
worth a lot more.
exactly, which is why we're not going to do that.
Yeah.
Is
Yeah.
your system open source?
No.
So it is a proprietary.
Yeah, I mean, there's nothing. The parts that are proprietary is, of course, the algorithms to actually solve these problems.
Mhm.
But in terms of what we built it on, it's pretty vanilla, if you will. Like we output industry standard G code, which is a language used by CNC machines to do the actual positioning, and then for specific robots that we deal with, we have a layer that does the translation between kind of positions in space into
Oh, so
that
you don't
robot.
necessarily build the
That's
robot,
actually
Oh, we
very-
build the robot as well.
but you can use other people's robots.
Correct. Yeah.
That's actually very interesting because that tech that you're talking about wouldn't only be useful for painting, but anything that would potentially use G code, like say for example, making a part.
Yeah.
You could just throw a piece of metal on it,
Precisely.
figure it out, take a picture, know where things is, know the general dimensions of it, and then make the part on the fly without doing the normal tooling stuff that you normally do.
Exactly. Yeah. Yeah.
Have you built a system for Taylor guitars?
Or
You're-
Taylor guitars.
Have you ever been out there and seen their tour? Take their tour. They have a station like this room because they're afraid of these robots hitting
Yeah,
something.
yeah.
But it buffs the body of the guitar, and it's really contorted. That thing goes in all kinds of directions.
Yeah.
It's I just sit there and think, man, that thing there's a million moves in that robot.
Sure. No, but is it the same guitar body though?
No, they have all different kinds of guitars.
I mean, like is each guitar going there through their like a
Well,
custom guitar?
What's the setup per shape?
Well, they probably do a run of certain ones.
Right,
But
right,
I,
okay.
but I, you know, the places, every guitar is almost different. I mean, they have hundreds of models.
Oh, I see.
They build.
I'm wondering, do you get any paint buildup on the arm? Oh, and also, how do you keep paint away from the camera lens?
Excellent question. So two things. One of the things that we've had to do, we've had to kind of become experts in something called making things explosion proof. So there's a very, very, very high standard called ATEX Class 1 Div 1, which means that anything that you deploy into an environment where you're aerosoling these highly volatile chemicals, it has to be made explosion proof. So our motors have to be explosion proof, our cameras have to be explosion proof. So the kind of solution that we have around that, I gave you a little bit of IP around it, but essentially what we do is we encase everything and then we purge it with air or nitrogen. And what that does is it creates a positive pressure anywhere where there's a spark, such that there's no way for those volatile chemicals to get inside these cavities. Now to buy these motors off the shelf costs like $15,000 a motor. So we're kind of forced to go and make this kind of technology ourselves.
What about keeping that lens clean?
Okay, so what we do there, we have a shutter on the lens,
Mm.
and what we do is we don't actually scan while we're painting. They're two separate processes. And what we do is we just rely on the fact that once something is in a jig or something is set up, is it's not going to move while it's doing well. Yeah.
How do you handle exclusions? Exclusions.
Exclusions as
Exclusions. Well, what you're doing is scanning it. Is there a
like occlusions? You mean like places we can't?
exclusions? Places
Like
where
a
you
window and
can't
a door?
Masking?
actually paint.
Where you mask things out?
We shouldn't actually paint.
Yes, places on a particular
Oh.
component that you shouldn't paint.
Right. So what we do is we have a bounding box that, once the thing is set up, that says that, okay, do not include any geometry that you see outside of this area in your paint path solution.
So you pass over it, and then you hand it off to a person to actually view it and to say okay, and then you press the button and paint.
There's two different kind of workflows associated with that. So if it's a particular class of product that goes through there, what happens is typically it falls into a volume, the same volume every single time, in which case they don't have to touch that bounding box. But if they're painting, let's say a door one day and a bumper, the next, like I said, then what has to happen is one of two things has to happen. Either somebody has to manually say, okay, this is the bounding box we're dealing with, or basically the part has to be recognized as being of this particular class and using this bounding box versus a different bounding box.
Was the Qualcomm accelerator program, did that do you good? Did you come across some entrepreneurs did that expand your business or give you more
Definitely. So the Qualcomm participation definitely expanded our business. I mean, BASF is actually the world's largest chemical company. And we're doing business with them either directly or indirectly because of our participation with Qualcomm. And we have a sale, with them for our systems. So
I understand Qualcomm dropped that accelerator program.
no, they
After
dropped
that.
the people who were running the program,
Oh,
namely
oh.
Techstars. Yeah, Techstars basically charges Qualcomm a lot of money to run that program, and they think they have like a brand or a cachet and so on. But Qualcomm brought value to the table for us, for sure.
You weren't in the most recent one. It was.
Yep.
Oh, were you?
Yeah,
Oh, okay.
I saw
I didn't remember.
Yeah. So, I'll show you another video.
Also, what is the
Yep.
approximate ROI? Yeah.
Okay, so the way we kind of did it for the collision industry is the economics, the unit economics are that. So let's take a bumper.
Uh-huh.
This is the most common part of the paint. And the reason is bumpers, when your car gets into an accident, 80% of the time it's going to be bumper damage. The other thing is bumpers are made out of urethane, and your car body is typically made out of metal. So because of that, there's no color matching issues. So they don't have to blend your bumper into your body or whatever. So bumpers are painted off car. So because of these, they're kind of the lifeblood of the kind of collision industry. This is why you see like bumper medic in places like that, but you don't see, door medic or roof medic, right?
Bumpers are the most things that get
Yeah.
damaged.
Right.
And they make them the color that matches the car
Right,
body.
and
so it
exactly. They
stands
don't
out.
inventory all the different colors, right? Because that would just be a huge inventory nightmare. So a bumper, basically, the labor cost on it is $100 per bumper. And the way this works is insurance companies pay the bill. Now what they do, this is kind of universal across North America and also Europe, and I believe Asia too, where for a particular make, model, year of car and type of damage, they'll say, okay, you get 4 hours of labor that you get to apply to this. Doesn't matter if you do it in 5 minutes, doesn't matter if you do it in 50 hours. We're still only giving you 4 hours for it. That 4 hours, let's say, translates into $100. So basically, by them putting the part in our machine and our machine doing the refinishing, we'll save them $100. So your typical body shop does about 60 bumpers a week. 60 bumpers a month, sorry. So that's $6,000 a month. So we wanted to get the ROI for this to be less than a year. So when it comes time to sell this to a body shop, it'll be about $60,000. So this will give them an ROI of less than a year, basically. That's kind of what we're shooting at.
Are these sprayers real accurate? I mean, do they form a real clean line? Can you rely on that?
No, it actually produces a cloud.
So it's pretty
Yeah.
foggy.
And this is actually the reason that we chose this particular problem set versus trying to kind of machine something really fine
Right.
out of the gate too. Just because painting is a little bit more forgiving than trying to machine a car.
Can you use this in other environments, like factory environments, where you use your visual acuity, if you will,
Yeah.
to see things that go wrong? For instance, like assembly lines, and all of a sudden you see there's something missing here. Or
Absolutely.
So it's an alert system.
Yeah, absolutely. Yeah, and it's fairly easy to kind of integrate that into a production chain. So
You
that's,
wouldn't have to build a robot; you just do your eyeball thing.
yeah, that's actually our very first sales are with systems that do exactly that.
You tried cooking, like the fry cook type of thing, where a robot could put a hand on it.
So there's an interesting company that started about 5 years ago called, I think it's called Momentum Machines, and they actually have a hamburger making robot. And the problem with the hamburger making robot, in terms of like all robots, is trying to get some kind of business model around it, right? Right now, I don't think McDonald's or whatever is quite ready for a hamburger making robot. What's going to happen if that thing fails, right? They need like a backup system and all this other stuff. So it's kind of hard to deploy it as a business. So what they're doing is they're actually making restaurants around the thing.
Right.
They're kind of emphasizing the fact
The question is,
Yeah.
could the robot cook better than a chef?
Can it cook better than a chef?
Yes.
Depends on the quality of the chef.
Well,
Probably something like a hamburger, it probably can. And the reason is because it relies on, you have this piece of meat, it's a particular volume, a particular size, particular density. It's going to be on the grill for a particular amount of time,
Right.
and then it has to be turned over.
All right, but let's say that you want to cook it when it's by temperature.
Yeah.
So can you measure the temperature relatively accurately? Whatever piece of meat you're cooking.
I'm not sure. I know they have like infrared, like non-contact temperature measuring devices that can measure the surface temperature and so on.
Right, and you put the probe inside. It's either internal stuff. And if you did it that way,
Yeah.
is that guaranteed that it would be cooked the best way possible, or there's still some magic that has to be put into that?
I would, if I were a betting man, I would go with the robot cooking it better than a human.
Because
If it were,
you
had
always
that
say
information.
cook it to 155 degrees
Yeah.
internal. You'll always
Yeah.
do that, regardless of the size of meat or anything else like that.
Yeah. Even when I've done a little work with meat, generally the rule of thumb is if you want to do it well, you use a thermometer to measure it anyway, not any special
You don't
tricks.
spitball it, yeah.
You don't spitball it. You just use a thermometer, and and as long as the thermometer and the shape is fine, you can basically get it down to a science.
Like
And as long-
Alton Brown, watch Alton Brown use it right in.
Exactly, yeah. And you realize the reason, like, these fast food chains, like, you could cook a McDonald's better than McDonald's, obviously, right? Anybody in this room can. But they're the ones that have this billion-dollar valuation. And the reason is, not because they cook really awesome hamburgers, but because they have a system to do it, quickly and cheaply and reproducibly, right?
Right.
So if you're talking quick, cheap, and reproducible,
Right.
sounds like a robot.
Yeah.
Right. And I think one of the things like McDonald's and stuff is that they're all overcooked. In my opinion, everything's overcooked. And-
Possibly for safety, yeah. There's a
Right.
part
Yeah.
of safety.
I mean, they don't really care.
Yeah. But you know what? Maybe using a robot, and that kind of the next kind of evolution of that is they could probably make a juicier hamburger now.
Exactly.
Right.
Yeah.
Because you remove the variability.
Of all things, McDonald's, those people, they are robotic. They are automated. Everybody, they hire the cheapest labor they can because
Right.
everything else is planned out. All of the ovens and everything
Yeah.
are calibrated.
Yeah.
They know all the French fries are the same size, and all the patties have been pre-made before they ever get
Yeah.
there.
Yeah.
So it is kind of a robot process anyway. It's
Yeah.
just got cheap labor.
They got meat-based robots. there.
Yeah.
Yeah.
So I'll show you a picture of kind of our actual robot, an earlier prototype we made. This one we made in Shenzhen, China. Oh, here the scanning head is actually right on the device. We've now moved to static, just lots of static cameras. Our kind of first inexpensive pan tilt head mounted on this giant XYZ gantry. So it's a large 7-axis CNC type robot. So there's the parts that scanned, and then this is our paint simulation engine, which basically allows us to make sure the paint goes where we say it's going to go, and then we actually send the information to the robot that actually paints the part. Since we're doing this in an office building, we didn't have the full-on spray gun. We had to use
Airbrush.
Airbrush, yeah.
Can you talk more about the cameras that you use? You mentioned you use some more than one depth camera.
So basically, the innards are very similar to what you'd find in a Microsoft Kinect. So there's two technologies that we use there. One is structured light cameras, so it gives off infrared light in a particular pattern, and then kind of looks for that pattern in the receiver, and just tries to basically create a depth map from that. The newer technology actually uses time of flight. So basically, an array of receivers kind of basically measures the time it takes for the information to get back, and we've gotten some very good results with that in terms of the kind of the quality of surfaces we've been able to build with that.
What kind of
That
sensors
That is
are
quick.
The Kinect 2 has it built in, $150 off the shelf.
Yeah. What type of sensor is it called to do that?
It's called a time of flight
Time
sensor.
of flight
Yeah.
sensor.
Yeah.
So you're saying they've gotten. Sorry, my mistake. Continue.
No, I was just saying. Sorry, but was that a video camera? That time of flight?
No, just depth. Just a depth camera.
It's just depth.
Yeah.
No, it's visual versus audio or something.
Oh no, it doesn't use audio. No, it doesn't. It uses lights to a different spectrum. Of course, yeah.
And it's off-the-shelf version. You just use the second-gen Kinect.
Yeah. I mean, we have to make a lot of modifications to it too, in terms of being able to meet the requirements for making it explosion-proof and so on.
So the idea of that system is actually you are able to count at you're able to count at a really fast speed to be able to measure the speed of light bouncing.
Yeah, essentially all that stuff's taken care of internally on the device. What's nice is it just puts out like a really nice an array of depths for us. Right?
Wow.
Yeah.
I mean, I'm just thinking of the amount, what the timers it would take just to be able
They
to count.
use some kind of it's a threshold, a diode threshold technology. Where basically they know how much time it takes like a signal to get processed to basically pass this gate. And
What does the data look like for this array?
I'm sorry.
What does the data look like? I mean,
So
it's a pulse, right?
Yeah. So per kind of element in the thing, but basically it has lots of it.
Right.
And it's able to process that almost in parallel because
And the data looks like a set of numbers, I assume.
it comes back. It's a very nice data set because it actually comes back in millimeters in an array that tells you depth information. So basically, each camera gives you 2.5D information. So what we do is we have this is kind of very typical of our structure. So we just at $150 a piece when you're selling these things for hundreds of thousands of dollars, we just put lots of cameras in the space and then combine the information from all of the sensors such that we don't get occlusions and things like that. Say, okay, this is our depth data.
Wow.
What's your preference for operating systems and programming languages?
So honestly, we keep it really simple. We're really old school. Windows and C.
Yeah.
Yeah. Nothing beyond that really. The glue, the higher level glue, the user interface stuff on the Windows is C# using just WinForms. Actually, not even using the newer kind of UI widgets or anything.
So you can work with Visual Studio.
It's all Visual Studio. It's funny, my CTO, he's very old school. He actually was running Windows XP and running Visual Studio 6 because he refuses to upgrade because his system is so stable with that.
Right.
It's good enough kind of thing. Yeah, we don't use ROS. We don't complicate things that way. We do use the same, for the actual controlling, the motion control system, we actually do use the same thing that you would find on an Arduino, although we don't use kind of the Arduino language. So we use the Atmel chip, but we just program it in C.
Or AVR.
Yeah, we don't, exactly. So that's really just the hardware side of things. What else can I tell you about it? The real magic is, of course, in the software. Kind of our whole, we tend to think of ourselves as the hardware is kind of a delivery mechanism for our software, which is where all the IP lies, all the interesting bits happen. And that's what the customer really pays for.
Could you describe a couple of the rough spots you ran into and had to solve software challenges?
Sure. Yeah. I mean, so we really tried to constrain the problem. So for the first thing we started, okay, we're going to paint an entire car, right? And if you're going to paint an entire car, you're going to need a really big robot, right? Mm-hmm. Then we said, okay, maybe not cars. Well, then how about car parts, right? Okay, yeah, smaller robot. But then you run into things like, okay, how many degrees of freedom do you need to paint a door, right? Because you have to get in there, get underneath stuff, and get around stuff, paint both sides, and things like that. So you run into the degrees of freedom problem, and as you know, when you have robots, the more degrees of freedom that you have, the more it's going to cost you to do something. So said, okay, let's talk about bumpers because all cars have them. Let's start at that kind of baseline for our product to get something out the door. And what's nice about bumpers is it falls into this kind of convex hull type of shape. Sure, there's vents and things like that, but there's never any kind of going inside and underneath something, or any kind of concavity where you have to paint inside like that. Because if you look at the typical back of a bumper, they're raw, they're not painted.
Right.
So that falls into kind of a good use case for us.
So then you could develop a mechanism that would just simply create the concave shape.
Yes. Yeah.
And
So
use that as one motion.
Right. Yeah. So we got ours down to our current arm is like a 7 degree of freedom machine. So basically 3 XYZ, and we have 4 degrees of freedom on the joint. That allows us to kind of get underneath things.
Okay.
What's the lower end of the scale? Like if I had some panel this big,
Yeah.
and I only did like 50 of them a month, or maybe 100, and you don't do anything any bigger than that. I mean, it's sort of a small. What's the affordability of somebody setting up
So
your equipment to do something like that?
So the very first robot we built, just on a video of it here, was like a 3-axis machine that we made to paint panels for a company that makes paint. And so what they do is they actually spray the paint at different speeds to find out how it behaves. So testing its viscosity, comparing it to previous samples, seeing where it starts to drip or what kind of speed you need to spray it at. So we built them that. We lost a bit of money on it, but we got a customer out of it too. And we did for them for like $5,000.
Oh, what made me think of it is my son-in-law works over here at Stratasys, and they build 3D parts for hospitals, basically the panels to cover robots so they're not intimidating to patients. So they make them smooth and friendly looking. Well, they have all these freaking panels they have to spray coat and put logos on.
Sure.
And they've got a booth like that. It's about 4 times that big.
Sure.
And there's a guy in there just suffering away all day long, going, and maybe you could sell this right over here in script, right?
I'd love to sell them a robot. Sounds like something that we've solved and we could really do. Yeah, that's the other thing is that there's a safety issue that a lot of people don't realize when it comes to things like paint. You have these chemicals in paints called isocyanates, and what the way they work is they bioaccumulate. So you could be doing this fine for 20 years. Your 21st year, your body has enough of this stuff, inside it where it thresholds, and basically you can't be exposed to this stuff anymore. So it's kind of nasty that way. It's dirty, that stuff gets everywhere, right? If you're aerosoling anything. Yeah. And obviously, dirty, dangerous, dull. You have repetitive stress types of issues because of the motion that they go through. Let me find you some more videos here. Yeah, so this is the machine that we built.
I'm just curious if this robot could have been built using, this Muse where they say they have all the parts. I wondered if you could build it from those parts, and then since most of the intellectual property was the software, then you could implement, your software on that. Or did you custom design?
We're working with Muse on a few projects actually. They were also part of the accelerator.
Yeah.
Yeah, but as you can see, we have this linear rail system.
All these robots, do they spray downward?
No.
Okay.
This one, for example, sprays straight ahead.
Oh, it sprays straight out.
And yeah, like you said, this would be perfect for painting his panels.
Yeah.
Yeah.
But I just don't know how many a month they do. I don't know how small a scale it would be before they could afford something like that. But
yeah.
if it was reasonable, I have a feeling they would jump on it.
Yeah. There's it's not only just a simple financial return on investment too, but basically anytime you have like a spray booth or something like that, you have a lot of accountability in terms of the regulations you have to follow with the EPA and so on, right? And if you take the human out of the equation, there's a lot less things that you have to.
I think they hack it a lot.
I'm just saying.
Follow all the rules.
Yeah. Some places you can get away with it for sure.
Yeah, it's amazing to me. They're making dental teeth in one area. They're making this rubberized stuff in another, and it's not all that far away. They're doing all this painting.
Yeah.
They're all those polymers they do the 3D printing.
It's everywhere. Yeah.
And I'm thinking, doesn't this stuff kind of get mixed together? Is that a problem?
Yeah,
That's
for sure. Let's see what else can I talk about. You got a question?
Yeah,
please?
actually, curious about the way that you detect the bumper. I guess you use the 3D cameras for that. Do you have kind of models that you use to know like this is what the geometry of a bumper is, or do you just kind of like look for where there's spaces in this 3D grid that's occupied, and is it like pretty general as far as like different bumper sizes and shapes?
Well, that's actually why we kind of chose bumpers as first. Is
Yeah.
yes, they're kind of a generalized shape like that, right? And kind of fall into the convex hull type of geometry. The second thing is that kind of following from your question about, how do you know what part to exclude? And again, with a bumper, aside from its overall size, they all fall into kind of a rectangular type of geometry that's within a particular space. So we don't have to go through each one and say, okay, this is where this bumper starts, this is where this one stops. The other thing is basically we have a little bit of IP around combining all the point clouds into kind of one unified mesh at the end. So hope that kind of answers your question.
Yeah, sure.
Yes. Hi.
Do you plan on making smaller versions for like Lego designs or something like that?
Yeah, I see that there is some applications. For example, I've seen where they take they make like 3D characters of people, and then I think that what they use is some kind of, it looks like some kind of inkjet technology, where they're able to kind of apply like a surface so it looks like a person. So that is one possible use of making a smaller version of that. But yeah, I mean, we tend to. So that's, I guess, kind of leads into the second part of my talk, is kind of like the business of robotics and why I'm doing it and why I think it's a good time right now to get into it. Basically, there's going to be a lot of automation that's going to be happening in the next 10 to 15 years in terms of a lot of jobs have been kind of automated to the point where maybe you still need to have a person there looking after 10 different machines as opposed to having 10 different people kind of running those 10 different machines. So you see that kind of that scale factor happening, in terms of having like a force multiplier. So these places that have like hundreds of employees, they'll eventually have, say, 10 employees, and those 10 employees will just be responsible for looking after, machines that are doing those tasks. So that's kind of where I see the industry going.
Has mind of its own. It won't work.
This becomes self-actualized. The other thing, so the business of robotics. So it's a hard business. Sorry, go ahead. Yeah.
I just had an idea.
Yeah.
What if you were to replace the spraying part with kind of like a claw? Then it would be able to make small things, as in like tiny little details physically, not painting it.
Yes, absolutely. That's definitely in our path. Once we get a lot of accuracy with our cameras, and once we see kind of an opportunity in terms of a very, very specific thing that needs to be assembled, where it makes sense for a machine to do it, that's something that we will have a machine do. We'll make a machine to do.
Can you borrow from the movie industry or all their what do you call it?
Motion capture?
Yeah, the motion capture that they really refined that so that they can take those measurements from an actor and then transfer them over to a model in a computer.
Right.
It's a virtual creature now that has your characteristics.
The funny thing is, a lot of that technology that they're using is our technology. My co-founder created a lot of the technology that is used in the motion picture industry, specifically to coordinate real life motion with CGI, computer generated motion. So basically, anytime you see like a real world, like the background with like some kind of special effect in it, or like a 3D character within that real world, they're using his technology to the synchronization of the two cameras. So yeah, so
They did a special the other day on how this new Star Wars thing was filmed, the background of people. And I had no idea. It was kind of interesting to me that while they were trying to figure out how to, when they take artwork, it was never fine enough to include in the movie. It was fuzzy, or it wasn't, resolution was not. Well, this guy figured out how to manipulate the pixels with some math formula, and he's the guy who started Photoshop. Really? There's the guy, and that's what did it. That was the problem they were trying to solve, and when he figured out how to manipulate pixels through algorithms, that became Photoshop. That's neat to know.
Yeah.
And there he is, even.
Yeah, absolutely. Yeah, I mean, it's really, we as a small company, we have to be really careful of where we kind of, deploy our resources. Like, we looked at the movie industry, doing things more towards that, but there's not a lot of money in the movie industry, actually, to tell you the truth, in terms of it's only like it's a $4 billion a year industry. It sounds like a big number, but in terms of like the amount of movies that they produce and everything, it's a very frugal industry. Let's say that.
Only getting more frugal.
Yeah, and also it's becoming so inexpensive to produce a movie, with the cost of like the cameras going down and everything.
You were about to talk about the business aspects
Right.
of robotics.
Sure. Yeah. So what I see happening is an acceleration in terms of these technologies being deployed and offsetting labor and all these other things. Now, we've seen this all before. We've seen it, kind of with the Industrial Revolution, and then with kind of like the Information Revolution. And I think, okay, well, this time, how is this going to be any different? And the answer to that is because those things were deployed at such a rate where people, society as a whole, kind of buffer that change. What I see happening now is if this thing is deployed in mass, technology like this, is it's going to create a real disruption in the workforce. And it's going to be a real change in how, work is kind of perceived. Like, I found an interesting stat, and that's that a salaried employee, the whole concept of it, is only like 200 years old. So maybe in the next kind of thing, what's kind of the next version of work, or what are humans going to do with their kind of time next? It's kind of an interesting higher level subject, but I see this kind of pushing that kind of
Do you see it
forward.
going back towards guilds and have a specialist that, a family,
well, that, and also I
father and a couple of sons are running a little
think, well, that father and a couple of sons could be running a multi-billion-dollar company, because of the leverage that they have. But also I see a need for maybe like a fixed, income for everybody in a particular, society.
I see things like that resonating, where you're seeing many more small companies that are exploding in their user base, and are now you're seeing, instead of the model where you have the salaried employee like you were saying, you end up seeing the entrepreneurial kind of development that makes services billions of people.
Right. And you see change happening all the time. If you look at the companies that are the big companies now versus like 25 years ago, a lot of them didn't exist, Certainly not 50 years ago. Yeah, exactly. Facebook, companies like that, Google, just turned 20. Apple, wasn't around for...
Big. But you look at what the regulation is in this country as well, and how much it's forcing businesses to look at being smaller, and it's encouraging that kind of, you're a small business, you only have a few employees that you're taking care of their health care, and everybody else is temps.
Yeah.
Well, it can multiply corruption just as much as it can entrepreneurship, I keep wondering, for instance, like AT&T and Verizon, these are the largest money makers in the world. They own the backbone, they own the communications. They are really more valuable than oil companies in what they control. But every month they increase the prices just a little bit. $1 here, $1 there. After about 3 or 4 months, you say, wait a minute, I'm paying $5 a month more. Multiply that by 12. So you call them up, and it's just all excuses. There's no reason for these prices to go up. They don't know. It's just somebody up there is making a bigger. Well, they already have all the profits in the world. So I keep thinking, well, what are they doing? Just pressurizing the society?
They're making money while the sun shines.
They already got all the money. I mean, how much do they need?
Oh, that's a conversation.
Have you noticed that your design could be used for many purposes? You can make phones with it. All you have to do is like replace the painted part with another tool and then just program it. It should be able to do it.
Right. There's a company in China called Foxconn. They make a lot of phones. They make iPhones and so on, and they're deploying robots now to replace their workers. And they said at one point in time they wanted to have like 1 million robots on the floor. They're not quite there yet, but at least they have the will to kind of get there. The other thing I noticed is other countries, like I spent some time in Europe, and this is like the first video you saw was with BASF, and I find that they're simply more willing to adopt robotic technology. They're a lot more comfortable with it than in North America, and I don't really understand why.
That I actually may have a little bit of an insight. The thing is the U.S. The thing is we're the economy, the education system, and a lot of things were tied with the concept of something called the interchangeable worker, and that's basically the worker that acts as like a robot. And as automation takes over a lot of the infrastructure in terms of teaching people and stuff, this is why you may hear about the new science, the new educational standards and stuff like that, is because the economy is shifting to a point where critical thinking and being able to have strong interpersonal skills with other people, which is one of the few things robots will probably not be able to replace, is human-to-human communication. Mm-hmm. And that is where the human is going to be more important in the economy from what I've seen. And so the problem is we haven't made the transition infrastructurally wise of being able to transmit people who do repeated tasks over to someone who has high critical thinking and is imaginative and is creative, which is what the economy is shifting towards.
Right. So we value that more here in North America than we do there, is that?
No, it's more that we don't have right now, the infrastructure of the education system right now is not set up to provide that climate. And so the problem is when you get people entering that, they start doing their work. They do work similar to what robots do. And the thing is the adaptation, the change in technology is changing faster than people who do that, than the ability of the culture and the economic infrastructures to adapt with that. And so now places like, for example, in Japan, where you have where they're actually having a population decrease, actually. This is less of a problem, but in our case, we have also a lot of lower income that most of their jobs are the types of things that robots can do. And so that is going to be the hard transition point, is because you're going to need a higher educated, stronger interpersonal skill, and the population in the country and its regulations haven't matched that yet.
Right.
And so that's kind of my overall view why that's happening.
Well, could it be that the Europeans also tend to have a higher labor cost?
Sorry?
The Europeans tend to have a higher labor cost.
Yeah. Japanese and Europeans, for sure. Yeah, labor cost, I think, factors into it.
Exactly.
Right.
One of the things about Europe I've always admire is they have a ergonomic system that takes care. For instance, as they build a city, they take care of the food. I mean, there's farms, there's people that raise fish. They stay organized as they scale up, and I don't think they feel as threatened. That robots are coming. They endorse the technology because it solves big problems, like how to keep the North Sea out of Denmark, or
Right.
Without that technology, they'd be in a lot of trouble.
Mm-hmm.
Germany, just as soon as they got some good solar cells, they went solar. As soon as they made some really efficient windmills, they went windmills.
Mm-hmm.
Or they do geothermal. We're just still talking about it.
Mm-hmm.
And as soon as it's there and it makes sense, boom, they do it. So they're not threatened by it.
Right.
So I think it's because their home base is solid. They don't have to worry about food going away because they're growing it right
Post-secondary education is free there.
They walk to where they're going to go. Everything is tight. We live in cars and everything it's so interdependent.
Mm-hmm.
We've got 4 or 5 grocery stores, like which Albertsons just collapsed up in the North County.
Right.
You could end up in a situation where you can't even get any food the next day because some business went out of.
Mm-hmm.
I think we're very much
I
more
think
vulnerable.
it's a lot more about the regulatory environment in Europe. You can't fire anybody in Europe. Here you can. So if you as a boss, you look at robots, it's really attractive because you don't have to worry about the costs of supporting an employee.
Yeah.
Costs of supporting an employee over there is huge compared to here.
Yeah.
You look over here and costs of employing someone is not as great. It's getting worse. It's getting hugely expensive now.
Yeah.
So I think you'll see that changing as you see the society becoming more socialist.
More social.
Well, I've also had a chance to spend some time in China as well, and that was really eye-opening. Kind of.
So then the question is, why is China, putting robots in places?
Why are they?
Yes.
Because the rate at which the country is growing is amazing.
Yes, but they still have millions and if not billions of people around.
Well, they do, but I've seen this firsthand. I've seen how a factory works. So here's Shenzhen, China, down here, southern China. Here's Hong Kong. Here's the rest of China, right? This area here is like a free economic zone, right? You think China's communist? They are the farthest thing from communist.
Right.
I have seen more expensive cars per square mile there than anywhere else in the world.
Yeah.
We're talking like Lamborghinis, Ferraris, Rolls Royces. It sucks up all of that and puts it right there. So these people, extremely economically prosperous, the ones that know how to leverage that system there. So what happens is they have all these fairly poor workers from farms and stuff come down here and they work in these factories. And I've seen these factories and the work conditions are horrible.
Yes.
I've seen something like fairly innocuous that you see that China's known for, and that's stamping out plastic parts. So they have these injection molding machines, and they're running, and kind of what qualifies for a factory is basically it's a large garage. Sometimes they have a dirt floor, sometimes a cement floor, but they have an injection molding machine there. No ventilation, things noisy as heck, and basically parts are coming out of it, and somebody takes the parts out and kind of takes it off like the tree, those old models used to get, to have all the parts on the tree, puts it in a box, sends it over here. And basically, it's a race to the bottom, right?
Yeah.
Whoever could do that, the cheapest. It's a matter of getting the molds made. These machines are commodity, and just getting that done. But the work conditions to do that, oh my God.
But is that the reason why they're doing it, or for other reasons? I think it's for control reasons myself, because they want to be able to turn on and off the factory as they want and make whatever they want without retraining a bunch of people or?
Here's the thing, though: is
How
the
can you
genie
make
is
it
out of the bottle.
How can you make it cheap? It's all about that in China.
Yes, I agree.
Yeah. Plus,
Plus, the
robots.
capitalist genie is out of the bottle now. You know what I mean? Is the central planning no longer applies to that region like it does everywhere else in China. So, anyways, the people that do this job, right? They do it for about 6 months, and then, oh, it's Chinese New Year. Chinese New Year, everybody goes home.
Exactly.
Right?
So they're losing control by having people there.
So what happens is, when Chinese New Year ends, 80% of the people that went home, they're happy at home. They're not going to go back right away, if at all, to this kind of horrible working conditions. Yeah, they're making more money there, maybe repatriating it or whatever, some back home, but
The value of life over the value of money.
And also, after all those people committed suicide at Foxconn, and Apple now started putting a lot of pressure on them to elevate the standard for
sure,
employees.
While
it's
still
kinder
keeping
and
it
and
robots. You
but
can
when you're talking
abuse
about-
robots, and
yeah.
there's no problem.
Well, they just had a chemical retaining lake finally fill up, and it broke loose and almost annihilated the whole city.
Sure.
In
So,
Colorado?
No, that's in China.
to that point, what happens is, so the two things, the reasons China is economical is obviously the cheap labor is there, right? But they also have the ecosystem there. So what happens is, oh, you want to make electronics? Guess what? You need electronics to make electronics. So there's the guy who makes the resistors, that guy makes inductors, that guy makes capacitors. They're all within a 50-mile radius of each other. When I went to China, I built this robot with parts all within a 30-mile radius of where I was in downtown Shenzhen. I could go across the street and buy the motor that I want. I could buy every single motor controller, everything.
Well,
Right
and
there.
politically, they're homogeneous. That's just like the Japanese and Japan Incorporated.
Yeah.
Because, Sony, Panasonic, they were all family members of those, Zubutsu or whatever it's called.
Well,
And
that's
so
it, yeah.
they all decided what they were going to do.
Yeah.
Panasonic made capacitors and batteries better than anybody. So that's your business. And then Sony did this, and Fujitsu did that. So they were never in competition with each other. They were all working on the side of Japan Incorporated.
China's a little bit of a different animal, though.
They just had quality
that,
parts.
They're shrewd. They know how to do business. It's extremely cutthroat there. Like, you have to be careful. Like, I've had this happen where if you order like a particular part, if you order an IC, what you will get is an IC, so like exactly the same plastic, externals, has legs, but the insides, they actually don't have anything inside it. They actually do not have dies inside it. And they actually sell these things.
So you have to be very specific and say, I want the one with the circuit inside.
No,
Write that out in the contract.
the trick is being able to. They have a ton of. They got huge number of suppliers,
Yeah.
but how many?
And
But the
they're-
trick is finding the reputable
Yeah.
suppliers.
Well, also, there's a lot of opacity in their supply chain. They like to keep it this way. So what will happen is you'll meet 100 motor manufacturers. Out of those 100 motor manufacturers, there's 3 people in the room that actually make the motors. And there's 97 that are kind of fronting them.
Yes. Yeah, I've noticed when I
If
see
you ever
things
go to
in
like
China.
Alibaba or something and try to buy things, I would say 80% of those stores are just like somebody who is a cousin of somebody selling motors.
Well, Amazon is doing them a great service too.
Oh, yeah.
There's thousands of products on
Right.
Amazon that are coming out of these little village.
Right.
And
Yeah.
there's just
So-
as many that are terrible parts that are absolutely worthless.
Yeah.
But
So-
they're so cheap, you buy them anyway.
Right, exactly. So all the money is kind of going to China. Their economy is growing at this huge clip. But now the guy who wanted $3 a day wants $6 a day the next day,
Right.
$18 a day the day after, like that. So it's growing like that.
That's life.
It's growing.
So what I see is not so much a reshoring because of the infrastructure to build cheap stuff is still there, but kind of a right shoring where maybe it does make sense to make certain things here instead of the kind of crossing the boat.
You have a huge problem. I lived there for a while, for about
Which
2
city?
years. In Shenzhen.
Oh, you did? Okay, yeah. I lived right in Huaqiangbei, actually.
Okay. I worked in Hong Kong, lived in Shenzhen, and the thing that we would always have a problem with is you train your employees and immediately they jump.
Absolutely.
And that's part. I mean, any and so the increase in the wages that that I mean you're starting to see that it's getting more and more expensive to hire the people that you have the extremely low skill labor, and you have the more creative types that you have to make sure that you keep them happy,
Right.
or else you lose them, and then they take your IP with them.
There is no morality around
None
IP in
at
China.
all.
No, there isn't.
Yeah.
Well, copyright has never really been a thing.
I mean, look at
It's worse than that. I work at your employ so that I can learn enough to sell this to the next vendor, to my next employer.
Well, you could always buy the bestseller, the latest CD, latest phonograph back in the old days.
That's
Off the black
never
market for 50 cents, so it's easy. And
Yeah, the rules of IP are very different. But
Yes.
also, like, I was really paranoid about what they rip off and what they don't. And typically, if you have like a high dollar, low volume good, they're not really interested. You know,
Yeah.
what they like to rip off are things that it has electronics inside, easy to make. I could make this for $1 and sell it for $3 kind of thing. If you could do that, then I'll rip that off all day long.
then they got a market with Amazon and eBay.
No, you've already established a market
Alibaba.
for them.
Yeah.
You're just selling into the same stream kind of thing. Yeah.
yeah. I've seen all sorts of things on.
So at what point in your company's kind of development did you go to China, or were you there
Right at the
during the
beginning,
beginning?
yeah.
Okay.
Yeah, so actually I did it through another accelerator called Hackcelerator.
Right.
So they hosted us in China. I spent 3 months in China learning how to build things, kind of, if I ever needed to build like kind of a more mass consumer product, at least I know how to do that now. I know who to talk to, and I know how much stuff should cost. I know the process to go through to not get ripped off and things like that.
Did you find that I've gone to all these meetings, I talked to all these Kickstarter guys on, well, and they all have to go to China to get the product costs in line. But one of the common threads I thought was interesting is they say to get around the buying the IC without the circuit inside, they all mentioned that they had to personally know the managers that ran these places.
Yeah.
It wasn't just a business connection. You had to do something for them to like you. You had to align yourself.
What you have to
very
do
close.
is to tell a big story, meaning that, so let's say you go to outsourcing manufacturer, not Foxconn, but let's say somebody a little bit smaller. What they'll do is they evaluate you on kind of your future earnings and like, okay, you have a cool product. Yeah, of course we're going to partner with you. What that mean by partner is, yes, you'll take the risk and we'll build a product. Kind of their margins and everything, they're all built in, right? They know exactly how much money they're making. They're not interested in risk. So what you need to do is to tell them, yes, we'll be shipping 100,000 units of this by next year. And of course, they get very excited by that. And then they put their A-team on it, versus some guy says, yeah, I just did this on Kickstarter. I need 500 of these things. You're going to get
We'll get
the
bigger
C-team,
later, maybe. Yeah.
Yeah. So you have to tell the big story, and you have to because that's it's at a certain point it's kind of about greed, because they want to basically invest in things that are going to make a lot more money. It's really simple as that.
Is one of the reasons you did the painting because of the lack of a robotic hand and so forth, the slowness of the dexterity of a manipulator?
Definitely the constraints were around anything we do. It has to be around things that are kind of realistically possible. Because the thing that I found out was, just even right now, is how primitive industrial robots are. They're great at doing like these repetitive tasks, but that intelligence needle hasn't moved a lot in 50 years. That's the really
and other
scary
than
bit.
suction to lift something or paint, or these are very simple manipulators, right?
Yeah. I mean,
Right.
Where you see some really cool stuff is the stuff like PC board assembly things are really cool, because they have these high-speed cameras that look at a board.
Pick and place.
Yeah, the pick and place cameras, and they're able to kind of very accurately, place parts and then inspect them and do all these tests in a very automated fashion. Like you see in like the assembly rooms they have
Just
over there that they're fast.
oh yeah.
It's all about it, but I wouldn't say that it's, I think the control systems are kind of dumb, but it's all about precision. It's all about repetitive accuracy. That's what everybody's been going for in it. And there's not been a concentration on going one level up and doing what you're doing, which is very novel.
Right. That's what we want to focus on. That's our kind of sweet spot. That's where we see the industry going eventually. And once more companies do that, that's when you'll see that kind of huge kind of shift in what's possible and more replacing of labor.
Have you thought about? I mean, this is probably next level is incorporating some kind of AI into your product.
So through Qualcomm, we actually met the people at IBM Watson.
Yeah.
So what's interesting about that is basically every time we paint something, we collect the data for all that stuff. So both the 3D model, the toolpath, and over time, we're building up this huge database, this huge locus of information. And what we want to do is basically put it into a system like Watson, where I could give it n parts, and it'll be able to figure out how to paint that geometry. So right now, it's somewhat constrained. We can do a good job on a lot of parts that look like this, but not an arbitrary part. So that's what we want to take AI, basically. So we want to involve AI once we have enough data to do that. That's the whole key behind all this deep learning and AI and stuff, is you have to have like a very large data set to work with.
Well, back to the AI thing. Is there a good way of measuring how intelligent something actually is? For instance, if you don't know how to paint something and the machine says, "We'll do it this way," how do you know if that's right?
Well, we have a simulation engine.
Well,
basically.
even then,
Yeah.
how do you know it's right after that?
Right. I mean, what you do is you just paint a lot of stuff, and hopefully you get better over time.
Well, and then exactly the issue. So, let's say that I'm in the business of providing expertise on how to paint something.
Yeah.
I don't know anything about painting.
Okay, so like you look at certain very, very specific things. So they actually have depth gauges that measure like the deposition of the paint across the surface. And when you're painting things like things for the oil industry, they have to meet these conformal thicknesses. There's a whole science behind that, and there's a whole kind of industry standard rating system and everything.
You're talking about the thickness of the paint?
Yeah.
And is that a minimum or a maximum? Or both?
So it's a minimum thickness, but here's the thing: paint is expensive. So you could meet the minimum thickness requirements by laying lots of paint, but it's a maximization problem, right? Because you want to meet the minimal thickness, but not so much that
you want to
use
minimize the cost, but to maximize the coverage or something like that.
what you just said.
Parameter might be corrosion.
Hansel had a question.
Yeah, since you've gone through both HACS and Qualcomm Robotics Accelerator, and then one of the things that QRA has been exploring is to see like robotics company can do manufacturing here in Tijuana or Mexicali.
Yeah.
What's, in your opinion, what's the pros and cons about potential manufacturing near San Diego?
So I looked at the Tijuana angle. The problem is it's still not as cheap as China. And one day that'll happen where that threshold will get crossed. I look at a business like yours, for example. I mean, China still makes sense, right? And the reason is because you have, if you look at the kind of parts you have, stamped plastic, bent metal, things like that, and in volume, right? It's still where you need to be right now. But if you're looking at kind of making a more precision type of robot, then you could certainly look at other areas where it makes sense too. Sorry, go ahead.
If you're talking about cheap paint, then wouldn't it be a bad idea because China uses worse chemicals than there are in paint for the paint? If you're talking about cheap paint.
Yeah, you definitely don't want to I think they have rules around like lead and things in their paint. I mean that we have that maybe they don't follow as strongly. I think there was an issue where they were painting kids' toys with
Lead-based paint.
lead-based paint.
Yeah, that was rough.
It's like the lumber liquidator problem.
Yeah.
They set everything up, everything was quality, it's stamped with quality, but they had too much formaldehyde.
Yeah, I also remember
See,
a story
China,
about where
you always have to look out for
Chinese
yourself.
were buying milk
Yeah.
from the U.S.
China.
Be safer than what they
Yeah.
could get locally.
The interesting thing, though, in terms of how the Chinese government looks at it, is the rules for exporting things are different than the rules in internal consumption. Like, if their people are going to get harmed by it, then they're a little bit more.
Is that really true? Because as far as I can tell, they harm the people all the time.
Well, I'll tell you, for example, like there was a scandal about where they were increasing the protein content in baby formula by adding like a very dangerous chemical. It was melanin in baby
Right.
formula or something. Like the people that were responsible for that were all executed.
That went worldwide.
They have that dog.
But it's because it was consumed in China.
Right, but I mean, there's smog, for instance. All their people reading that smog. What are they doing about that?
Well,
They sued
They're all-
Volkswagen. For the-
yeah,
That
I mean,
explains it then.
That's also
it's
one.
it's the cost of growth, right?
Right. But it seems to me that they are sacrificing, because, I've heard, I don't know, but, chemical spills are all over the place. And,
Look what happened.
the groundwater,
in
the ground
chemical
waters
explosion
are all getting polluted
that
by.
happened in
That's,
China.
that's business.
In one of the
Well, maybe
shipping
this is-
areas,
Well,
they just had
China's
chemicals
interested
in
is
it.
they want to be very homogenous and like, okay, this is the country of China. This is where we're at today. This is where we're going to be in 5 years. And guess what? We're going to be there in 5 years,
Well, what
no
does-
matter what.
What does being there mean?
Be there means that if they need to build a road between here and there, your house is in the middle.
Right,
You know,
that house goes away.
That house goes
But
away.
Are they saying in 5 years we're gonna have, 20% of our population employed, or 10%, or 60%?
In the context of the people, I'm not
Yeah,
sure.
see,
I
think
don't
so
know.
either. Right, I think they look at it this way: if we can afford to buy more Mercedes, we're good, and that's all they care about.
Well, no. I think the Chinese government wants China to be. It already is in many ways already more of a first world nation than North America. If you go there, like the big cities are incredible. If you've ever been to like Shanghai or something,
Yeah.
there's no place like it on earth. Right? I mean, they're far ahead in many ways. I don't think the Chinese government is interested in like purposely harming its citizens, but I do think that their agenda is their agenda, and they're kind of, if they have to break a few eggs, kind of thing.
Well, we tend to be very precocious, because we've been on this high plane for so long. But if you go to Orange, New Jersey, to Edison's laboratory, there's a letter in there that just blows me away. When Edison invented the lead-acid battery to go on railroads, so they'd have lights on railroads, all these workers came in to build the first lead-acid batteries. Well, the lead was getting into their water where they were washing their clothes and everything else. They were getting sick. It was killing people off. And they protested Edison's factory. Said, you've got to clean this up, do something about it. And Edison wrote a letter to the governor of New York saying, these people are impeding progress. What do you want, progress? Or, they can move. And Edison was supported all the way. I mean, business was far more important than these people's lives. When was that? That wasn't all that many years ago.
Oh yeah, business. You'll see this as things, and this is going to happen more and more places. Business is going to be king in as the world progresses. The question is, that's not going to change unless something catastrophic happens that says otherwise.
Well, what changed America was the unions and civil rights and all this sort of thing. It just hasn't happened yet. So we shouldn't badmouth these people and look down our noses.
Oh, no.
It's just,
That's just nature.
things are going to get better there.
Absolutely, yeah. That's the thing too. Is the news portrays like the worst of it too.
Oh yeah.
It's so skewed how everything is portrayed that it's not fair. They have to manage 1 billion people, and they're doing like a really good job of it. My ancestry is Indian. I've never been to India, but from what I've seen is they need kind of that kind of organization kind of happening
And
there.
how do you handle that many people's opinions if nothing else?
They
Right.
ask for their opinion.
Don't ask for it.
Well, I'm just saying controlling that is really hard.
Oh, do they have general elections and stuff like that? Where does the
Well,
masses get?
China's still a
not the
communist
same.
country.
They don't vote. Yeah, China. It's It's what is called an authoritarian regime. They basically say your guys are going to do this, and you will do that. For the
Well, it
most
depends
part.
on whether you do that harshly or you do that nicely. In Japan, we consider it a democracy, and it's not. It's a socialistic democracy. It always has been, where what's decided is flowed down through these family, but they're all benevolent. They're all looking out for each other. The thing about Japan that's always amazed me is every single individual, they find a place in life for them. If they don't make it through school, they don't go to college, but they're positioned somewhere. Not everybody's going to be a PhD engineer, but in this country, everybody's number one. Everybody is, you can do anything you want. We promote just the opposite. Oh yeah, let's make this guy. He can't add 2 and 2, but let's make him a rocket scientist, so he'll feel good. That never happens in these
So you
countries
become a rocket scientist without doing
because
any,
you've got talent. That's the only
You
way
have
you're ever
talent.
going to get there.
Yeah.
not because you can't add 2 numbers here.
Now, if you do that, you're probably going to be counting things in a factory. But at least they're taken care of.
Did you face any major
Ignore it.
liability issues? Just like so that before it starts up, people are all removed from the work area and all that.
Liability issues?
Liability.
So with the Germans, yeah, they're very, very cautious about things like this. So the room that you saw, the suppression equipment in that thing is amazing. And, okay, so they have in this enclosure where they're painting things, they have a fire suppression system. And what they do is it's a flash detector, so you can't actually take a picture with like a flash camera or anything. That's what it does. It sets off these. They basically fill the room in 17 seconds with CO2. So you have 17 seconds to leave the room or you'll die.
Yeah. I remember something like that.
And so they take their liabilities very seriously. And also they even had their own fire brigade standing by, kind of thing, because they don't want anything to happen. So they're very, very, very risk averse. And before I could deploy my equipment in this room, they evacuate the air every like 30 seconds, kind of thing, because the airflow. And I actually had to check it with something to make sure that the VOC content in the air was lower than a certain amount and everything. So for what we're doing with them, we said, okay, this is just too much for us. So what you're going to be doing is you're going to be doing your scanning in this area outside of the paint booth, and then you're going to put it in here, but it's going to be in the same jig, the same fixture, such that we know exactly where the part is. But then we basically got rid of that whole problem altogether of the...
One thing is when you have a robot in there, as long as it meets their requirements of not blowing anything up, then they then they'll allow it. But you need to prove that it doesn't blow up.
Right.
So do you have any path into the Internet of Things where you get into commercial homes, right down into the nitty gritty?
Now, that's something that, so being in these accelerators, we saw lots of companies doing things that are kind of consumer facing. And I have to tell you honestly, I do not like consumer facing things as a business because you're taking a hard problem and you're making it harder. Because you have this problem where I have to keep this one customer happy, selling them a $100,000 piece of equipment, or I can keep 100,000 people happy by selling them something for $1.
Yeah.
And selling them a thing for $1 is sometimes just as much work as getting this guy to write his check.
Yeah, the assumption is the average guy's going to be able to pay for all this stuff. A cell phone, just communicating is up to $200-300 a month for the average person. That is ridiculous.
But it's become commoditized to hack. Like you look at Qualcomm, these guys like they own the chips that do this stuff, right? And they're having a hard time because now, okay, they've saturated this market, right? There's people coming out with cheaper and cheaper and cheaper solutions, right? When you got people with coming out with like a sub $50 smartphone that did everything better than the first iPhone did, you know,
There's also
it's like how much more margin are you going to squeeze out of there, right? It has to come from somewhere, right? And you got these guys in there, they're selling a chip that goes in there. It costs them, 10 cents to make, and maybe they're selling it for 50 cents, for example, right? That's like they're making 40 cents on it kind of thing.
yeah. I mean,
That's a place to squeeze because you're not going to squeeze the guy who's selling like the 0.1 cent resistor, right?
So did your approach or business plan change much as you went through these accelerators? Or did you find a team?
Yeah. So obviously we still have the long view of kind of doing it for like the collision industry and stuff. We just got so much traction in just good old-fashioned industry. For example, we're doing a project now where we're painting pipeline for the oil fields. Now, even though oil is like super cheap right now, what has to happen is that pipeline has to get dug out of the ground, resurfaced every now and then put back in place. Because if there's any kind of break in those pipelines, it's like a huge disaster, environmental and
and also a lot of money.
yeah, and
Money lot.
If oil ever stops flowing, it's like money like just down the drain for these people. So they have to continuously service like these pipelines. So we're making a robot that basically goes and resprays these pipelines automatically.
From inside, it's respect.
Inside.
No, on the outside.
On the outside, that are buried, or the pipes aren't buried.
They dig them out,
They dig them out.
and they have to be sandblasted and then resprayed, then put back together.
Work.
Yeah, good job for robots.
Which is why there's probably some form of redundancy in some of the things they do, just because they have to have certain things. They have to calculate how much downtime of certain bits and pieces, so that way the oil's constantly flowing.
They hate downtime. Yeah.
Downtime, even a second, is
Yeah, Dave, it's
painful
even
for
worse. We have a bank loses a trunk line, and there's $1 million a second going through that data.
Yeah.
And it goes off the air, it goes dark.
But the difference is you could recover from that.
Yeah.
They just do more transactions later. But
Yeah.
oil coming out of an oil pipe,
I had a friend that was in the Air Force. He moved to Dallas. He was an expert with phones. So and this was back in early 70s. These big banks had never thought about disaster preparedness for their data systems as they all just started depending on. So he built since Dallas is a major hub for almost everything going through trunk lines going through the United States. ATT is a huge center there. They went and got a building, and they because they knew which trunk lines they could bring in there, and they rented the space for banks, all those big banks in Dallas, to bring their backup equipment to set it up in case they had a flood or something broke, their building burned down, whatever. And that room sat empty for 10 years.
Mm-hmm.
He retired on the money he made renting an empty room to those major banks.
Mhm.
I thought that was the most brilliant scheme I've
well,
ever heard of.
it's insurance companies, right? Who are the biggest like wealth? You know Warren Buffett, right?
Oh, yeah.
Second, third richest man in the world. You know what makes him the second or third richest man in the world? What's his largest holding? He owns 70% of a company called Geico.
Yeah. Well, that's like Ross Perot.
With
He
Pro
did the
Systems,
books.
EDS.
He did the books for everybody. He does the books for Saudi Arabia, for instance, in Dubai. People like that. He just does their books in COBOL. And it's, $1 billion a month.
So, what part does regulation? How much of your business is dealing with regulation,
Right.
and how much is that is that costing your business right now? And
Excellent question.
what are you doing to make sure that you stay on top of the regulations worldwide, both here and worldwide?
Right. And that, again, excellent question, because it totally influenced how we go about our business. So when we're doing this, when we're executing on our larger vision of the collision industry and having robots paint parts for accidents, basically. Now, how are we going to deploy this? And then we looked at, okay, what is the reality given I have only a little bit of money, I don't have that much reach, don't have a huge operation center. How am I going to make this thing grow, right? So the problem is, can I realistically deploy robots into, a service garage right now? I have to make it so robust, right? I have to meet all these standards and so on. So the reality of it is that, let's not solve the problem that way. Rather than selling the robots, we're just going to sell pre-painted parts to those service centers for less than they could paint it themselves. So basically, I'll set up something on Mira Mesa here. There's 50 body shops there. And it'll be pretty quiet because it's not going to meet all the standards that need to be met. But it'll be robots will be painting parts in there and servicing that local area. So, one of those locations could service all of San Diego. Set another one up in LA as it grows. We go down the East Coast and kind of grow organically like that.
Is there enough business pressure on you to have a lobbyist that represents your industry and what you're doing in Sacramento and in Washington, D.C.? Because,
A lobbyist?
all the big businesses, they keep the government from interfering with what they do by
Well, the
having
government in my
lobbyists
context
sell their
isn't
point of view all the time.
interfering because, we do need to meet certain safety guidelines and so on. But, where the amount of certification that I have to go through is very onerous. So if I'm
when
consuming,
you find something absurd,
what I'm saying is
but
that if
it's-
I'm
you have to
consuming
pay
the
for it
robots
anyway.
myself and nobody knows, nobody's the wiser, right? Doesn't really matter if that machine is certified according to oil or not. Probably not, right? Because I'm taking all the risk, right? It's my factory that's going to blow up, not yours. So having said that, I think it allows us to kind of automate this process without kind of exposing our technology to everybody, or
So you're looking at actually changing your business model because it's difficult to meet the regulation requirements in order to get your technology into the body shops themselves.
Absolutely.
It's much different when you're doing the service yourself or if you're selling equipment to other people.
Right. By doing the service ourselves, obviously we're leaving a little bit of money on the table, because we're not getting that huge, capital sale. But that's okay because we get the reoccurring revenue.
Yeah.
all you hear is the bad stories about lobbyists and everything because they're sensationalized, but it's a reality of life. When I worked in the aerospace business, all the ISO standards, we had a team that always went to every ISO conference, studied every single rule change, figured out how it would impact General Dynamics in this case. And if it was silly or had something that was incorrect or we couldn't do, we would send a team to those agencies and sit and have conferences. There was like hundreds of people just watching the rules.
Sure.
Yeah.
I mean, when a company like Uber, they raise billions of dollars, and that's what they're spending their money on. Me, I'm a little guy, and I'm okay with working around the rules for now, rather than trying to change them. You put a roadblock in front of me, I'm not going to fight it. I'm going to work around it.
Lobbyists are for those that have money to do it.
Yeah.
And frankly, when you're getting that much, you're making multi-million probably, or billion. Or at least you're starting.
Right. So I have to get to the point where I have like a high class problem like that, right?
Right.
If you have a small shop to service all these other places, then you can actually franchise that, right?
Precisely. Yeah.
And that way, because working with a franchisee, you'd have a lot more control over the regulation probably versus a customer where you can have just...
Right. And the reality is what it does is robots break, right? It's a fact. It's a machine. They break. So if I have these robots out at these different shop floors, it's going to be a nightmare. I'm going to need such a support staff to support all those robots there, right? Versus using it as a force multiplier, where I have one guy who's an expert at taking care of my robots, making sure they're constantly up and running, and he's just pumping out bumpers and bumpers and bumpers, you know, to these body shops every day, making a smaller transaction, but making it every day continuously.
Sustainability versus growth.
And it would be an easy decision for the shop because they don't have to look at the big capital
It doesn't
outlay.
change exactly. There's no capex for them. It also doesn't change their workflow that much too.
So we are actually officially
Okay.
15 minutes past. But thank you very much, Ashley.
Yeah.
Thank you very much.
And then maybe you can stick around for the next 5 10
Oh no, I'm here.
minutes.
Yeah, no, it's just fun, just kind of talking about this stuff.
Yeah.
Do you have a business card?
I'll give it to Jay out there.
So just a couple announcements is so we'll be having our first so this was our meeting last meeting this year. So until we see you next time, Merry Christmas and Happy New Year. Our first meeting next year will be actually not here. It's gonna be at Coleman University with the unmanned accelerator that they are pulling together. So it's gonna be at Coleman and January 5th, and then on following week we'll be having actually first robotics team come in. So they're gonna bring their robot. It's the team that they're working on the first robotics competition. Yeah. And then if you guys can do one small favor, actually our company RoboLink, our new drone platform is selected as one of the top 10 innovative products at CES. So if you can help us online voting, it takes like 10 seconds. So I'll give you the link individually, and then if you guys can help us to promote that, that'd be fantastic. So thank you very much.
Okay, let's get going.
Thank you very much. I really
Absolutely,
enjoyed it.
thank you. I
Yeah.
hope you guys got something out of
Yeah,
it.
yeah, it was really very
Very interesting to me. Remember.